explosion. So we all on the stream still see the QR code. Oh, but I hear myself.
Oh, yes.
Cool. Okay, so we have voice.
Yeah. Okay.
But no picture.
Soon. I'm switching the scene.
Oh. Infinity.
A bit of Inception.
Nice. So strange to see like ourselves like 3 times.
So this is the first time I'm now hosting multiple people. Let's see how this works. Hello world. Thank you very much for joining in. Today is the 20th birthday of .NET. I am most excited to be joined by Benjamin Nitschke and by Hendrik Müller. We have both met when I moved from Austria to Germany, and we share a common love for .NET, and we will find out in the next hour or so why we love .NET and why .NET loves us according to the to the Twitter or social media hashtag. So perhaps let's introduce ourselves a little bit. My name is Stefan. I have started streaming a couple of weeks ago, and I thought this would be a great opportunity to talk a little bit and share our experiences with .NET over the last, well, for me, it's only 10 years. I have started .NET in 2012. I started actually with Unity and with Mono. Not sure what language version that was. Then in 2013, then went to .NET Framework, and then this passion, together with my 2 guests today, wasn't forced, and now I'm stuck with this with this passion. I'm also on GitHub doing a couple of projects. Also do at meetups and at conferences some talks, and pretty much everything .NET. So Benjamin, would you like to introduce yourself?
Trying to get my background.
Oh, excellent.
Maybe Henrik wants to first introduce himself.
Yes, so my name is Hendrik Müller. I'm a professional .NET software developer for now exactly or almost 10 years. I've worked in the game, travel, healthcare, and logistic industries. Yeah, and I'm doing .NET. I've started with .NET, I think, like 12 to 15 years ago, back during my high school time. And I also tried like Java and PHP and Basic, I think, without Visual Basic, just Basic, yes. Delphi. We also did some Pascal in school, I think, but for some reason I stuck with C#.NET. I cannot remember exactly. I think there was some IRC channel where I hung up like ages ago, and someone just mentioned this language, and then I got hooked to it immediately. Yeah, and since then I stayed with it and enjoying it every day, or mostly enjoying it. Sometimes I hate it, but overwhelming positive. Yes.
Cool. I finally got my background picture.
Cool.
But for some reason, Zoom mirrors it, so I have to re-mirror it. It's a bit confusing. Okay. Yeah, I'm Benjamin Nitschke. I'm the CEO of Delta Engine. So both these other guys were my employees a long time ago, but now they're very successful in other places. So Stefan is in Austria, and yeah,
good job, Benjamin.
Henrik is still close by, but he's working in many other companies, as he just explained. Yeah, so I started as a game developer when I was really young, like 9 years old in the 80s. And just used whatever like the computers could do, like Atari had their own stuff, and then Microsoft on x88 stuff like x286, like the first versions of the Intel, where Microsoft like was dominating basically everything with their basic and like programming and DOS and all the stuff. And yeah, so I started with a Commodore CS64 and used the basic there. which kind of was the only language like 90% of people used. And then later used lots of C++ code and Pascal. I really liked Pascal and Delphi, but the problem was like game development was not really possible in those languages. So you always had to be low-level assembly C++ stuff. Till Java came out, so I liked Java a lot in the late 90s. But the problem again was there's no game development going on, and the language was really bad in the beginning for any kind of management of game stuff and fast game loops and stuff. So you could do like cool stuff like the Java applets, maybe anyone remembers. So directly in the browser, you had like a piece of Java code that was running, really cool. And then 2000, Microsoft announced their new .NET platform thingy. Like they said, like it's the internet future, whatever bullshit. And then 2002, finally Visual Studio .NET came out, the first version with C#1, basically .NET 1. Yeah, and then I was basically already using it from the beta and started to, it was kind of funny time because we started our new game project. And the game we did previously was completely written in C++, was like a strategy game. That was supposed to run on the browser, but then later it just became a normal strategy game. And the publisher went like bankrupt. And then we said like, this is stupid. Like we have such a good game and idea. Let's make a proper game out of it while we were still students. And basically I was the first guy in the world that made a commercial .NET game in 2002.
Maybe you can just name it. I think you're talking about Arena Wars.
Yeah, Arena Wars. Yes. Maybe I can show a picture. We can try our screen sharing.
The Nostalgica. Nostalgia?
Then you can see what kind of a game it is. So, whoop. You can just share my screen. Still in the stupid options dialog. So, share screen, screen one. Yeah, why not? Doesn't matter. So it was like a strategy game. So the very first version looked like more like this. So this was like early 2000s. And then we made a new version, Arena Wars 2, that was later then on Steam. Steam didn't exist yet when we did this. But then later we published the second version on Steam. And basically the game was like using the webcam feature, like in the time when no one really had internet. We had like voice and replays, and people misused it a lot. They were like showing like TV stuff like football games and stuff like that in the game, just join the game to watch TV and not actually play. So because it's kind of funny. And the main game was like very competitive. So it was like capture the flag, but in a strategy game. And yeah, it was very action heavy, like Quake 3 basically. But yeah, our main problem was like most people didn't have fast internet, and our single player was non-existent. So it was a pure multiplayer game in a time when there was no multiplayer. And nowadays, like almost everything is multiplayer with PUBG and so on. Yeah, so that's how I started. And yeah, nowadays I'm still doing a bit of game development. We have a small team of that, but our main focus is currently robotics and AI. Yeah, and I'm still using .NET, like it, and C# is really good, especially the last few years. Yeah, let's talk about that.
Oh, I now have the déjà vu of actually I played Arena Wars more than 10 years ago, and this is when I actually then applied to Delta Engine.
Yeah, I got him.
So this was my this game kind of butterfly affected me into now. Just so very amazing. Good. So you mentioned what has developed. You started, Benjamin. You started even before the full release already. Myself started 2012. Hendrik, when did you start with .NET actually?
Yeah, on a professional level, 2012.
Mm-hmm. And so, how was it before? How was .NET in the early days, Benjamin?
Yeah, I guess then I have to talk about that.
from your point of view.
So first of all, there was nothing. So there was basically no reason for any game developer. Most people had their own engine, but the biggest one was, I think, already Unreal Engine, and everything is C++ there. So anyone used that. There's no point. Still till today, it's still the same code base. It's still C++, and there's no point of anyone trying to convert it to any other language. So that was the main issue. Like anyone that had anything written already could not just switch to a new thing, because even though Microsoft tried to make like C++ manage C++, so you could take your old code and get somehow the .NET stuff in there as well, that never took off. Doesn't make any sense. So for C#, you basically had to start from scratch. You had to use a new, you understand the framework, which is, I think, the main reason why the language is so successful, because you have this huge framework that provides you like 80% of stuff that you need. And then it's not that hard to write more code, as opposed to like for C++, you have nothing. And plus it's super hard to write any new code. Like it's doubly hard. And yeah, so in the beginning, I wrote my own OpenGL wrapper, basically. So since I used OpenGL in the 90s already, and then in Java, I wrote my own wrapper as well. Then it was like an obvious choice, like in C++, yeah, let's try that again. And basically the code base, you can imagine, is like 20% C++ code, like old code I had before. And then C# code is calling that through pinvoke. And then lots of C# code for all the logic and the game stuff. And yeah, it took like over a year to write all the wrapper, and it's huge code base. It was, I think, in the end, over 1 million lines of code. But it was way before I did like proper test-driven development. So there's sometimes a test at the end of the class, but in no way it's like test-driven. So it's just a mess. I think the funniest class is the, it's I think called Unit Manager. And it's a thing that manages the units. But the problem is everything in the game was a unit. Like the tree was a unit, the units you can play around, the buildings were units, and even the effects were units. So everything was handled in this single class, plus the whole AI and everything was also in there. So in the end, I think the file was like 50,000 lines long or something. And I think for Arena was too, we split it up into like 10,000 and 5,000 line long methods and classes. But it's not the way I would write code right now. So now our limit is more like 100 to 300 lines. So more is not even allowed. So it was very different time back then. So you can imagine like you looking at the source code, and it was like a huge tree of like going up and down in the indentation. And basically you just remembered, oh yeah, the place where it was like 8 indentations long, that was a place that was interesting. So you just scrolled down and looked at the place where it got like crazy. And then you said, I found it. Now let's fix the bug. And then obviously it took forever to fix anything in that huge file. Yes. Yeah, but in the end it worked. And the important thing, the performance was really good. So everyone didn't want to use .NET and C# because of the garbage collection. And that's usually a problem in a game. Like if you play a game and you want to have 60 FPS, you don't want to have some crazy process from the side kicking in and then collecting some garbage, which kind of makes sense. You have to do that in a normal app. But in a game, when you want to run 60 times per second, and then the stupid garbage collector like takes up half a second, your whole frame will drop down to 2 FPS and then go up again. And this is like really, really bad for any kind of game where you want to like really have like shooters and stuff where you really want to have like a fluid experience. And the solution to that is kind of simple if you think about it. And now everyone obviously does it. And it's pretty much what Unity also does. It's just allocate everything you need in the very beginning in the loading time, and then just let the game run and never delete anything. So just keep all the objects around and just replace them with new ones. So we had a really simple concept that every user could have like 20 units. So we just in the beginning created 20 units, and then just replace 20 units like with the type of unit it was. But either the unit was in the non-state, so not used, or it was in one of the states of the units, or it, as I said before, it was like a tree, or it was like anything. And basically that's how we managed. So basically at loading time, we created everything, and then the game ran. And then when the game was finished, then we called the garbage collector ourselves. So we disabled it completely. And then everything was cleaned up and the next level was loaded. So loading time was a bit slow, I would say. Like it could have been faster, but the advantage was the game itself had no problems. Like it always ran completely fluid, and we really had high frame rates. Like in our unit tests back then, I think we had like 10,000 FPS or something. So that was pretty good. So it was not a problem that performance on the graphic pipeline or anything was slow. But when we came out, like it was 2004, that was the time when Half-Life 2 came, Doom 3, and Far Cry, and they all had like crazy amount of shaders, and we had like this little shaders in our game. Yeah, so it was like not like super high-tech stuff. That was basically what we did in the years after. So in 2005, I just learned about more shader stuff and built like a whole shader tools and all this kind of stuff. And then XNA finally came out from Microsoft. Maybe you guys used it as well.
A little bit.
Not really.
Not thoroughly, and a little bit.
Sadly, it's dead now, but basically it came, like it was announced in 2005 and then came out end of the year. And I wrote a book that also came out together with the thing, like was a few months late, I think, because of the publisher, but I finished writing it before it came out. You can just show you quickly. Can I click on this? Yeah. Oops, sorry, bams. So this book basically I wrote, you can see me in my younger years. And yeah, this was like 2005, 2006. And then XNA was always like for hobbyists. It was like very targeted for students. And I wanted to force them a bit like to target it more to professionals. Because it was possible to build like real games out of it. And now with Unity, like everyone would say, yeah, obviously do that. But back then, no one thought that. Everyone was hating any kind of managed language. No one even talked about like Ruby, PHP, and everything was dead, basically. There was only C++, and there was like some people using like Java for like servers, and some people used like front-end stuff, Windows Forms, but no one was thinking in game development you could use anything except C and C++. Yeah, and I wrote the book and became MVP for Microsoft. It was really fun for a few years. Yeah, and sadly, Microsoft stopped it at 2010, and I also became like less interested because I noticed like they're going on a strange road with only students and stuff like that. Yeah, and sadly, XNA is dead now, but I hoped it was like really successful. Yeah, but what can you do? Microsoft just kills the project; they don't care and do something else. And since then, we used lots of tools. Yeah, probably you guys know as well, like Xamarin and NuGet packages. We should talk about that a bit, maybe.
Ooh, yes.
But do you know why XNA was abandoned by Microsoft? Like, is there a specific
It was not
reason?
successful. The problem was it was only targeted to students, and they didn't think like the next step, because it's much easier like the Unity way. Just say it's free for everyone, for the students, but then the companies use it, and then the companies hire the people that learn Unity. And Microsoft never did that. They only targeted like students, but never targeted any company. So no company ever used XNA, like except for really tiny indie games. So they didn't hire many people, so it didn't have a big impact.
So you mentioned performance, very important. I think the pattern to allocate before and then reuse, is that the object pool pattern?
No, basically back then that didn't exist. So basically I was at a conference in 2005, the PDC, I think, Professional Developer Conference in Los Angeles. Really nice. Microsoft invited me, paid for everything, like first class flight. And I was like still very young and in my 20s, early 20s. And I was like, whoa, this is cool. And the trick was Microsoft wanted to hire me. So they even invited me for 2 weeks to work over there and check out their offices and so on. It's really nice. Yeah, but I declined. I wanted to stay independent. And the thing, I was in this conference talking to the main guy that was like responsible for performance in .NET, Rico Macchiani, I think is his name. He's still like a project manager in .NET. He's really famous. And back then, I just talked about him. Hey, I made a game in .NET. He was like, what? That's even possible? He was not aware of it. I showed it to him and he was really impressed. And then we talked about performance. And he said, like, that's very unusual way you took. Because you took out all the stuff that we did for optimizing and like disabled it to make it fast. So it was kind of funny talk, but I think he got it what I did, and he said like that's the best choice to do. And I think nowadays every game does it. Like every good game allocates as much as possible in the beginning, has like object pools, as you say, and then basically just keeps them like stable. Maybe there's a minor garbage connection, but you don't want to have like hundreds of megabytes like being collected and merged and fragmentation and stuff like that. I would say it depends on the game. Like if you have like an open world game, like if you have some World of Warcraft or Far Cry, you cannot avoid it because you're running around, see new stuff that you didn't have before. You have to delete the old stuff you don't see anymore and have to do this constantly. But in a strategy game, like let's say you have StarCraft or something, or Age of Empires, just load everything in the beginning and it's not that difficult. Like you can just allocate everything. In a shooter, I guess it depends. Like if it's like a shooter that has level by level, I think we're both playing Serious Sam right now. So that's very easy to just load the whole thing. And it's not that much geometry. And that's usually how, I think till Gears of War, every game did it like that. And then they changed it a bit. with their streaming technology. So level were split in small parts, and it's much more complicated nowadays, obviously. Yeah, but that's basically but it has nothing to do with .NET. Like you have to do the same shit in C++ and Unity and in Java. It doesn't matter. You just have to find like a proper way to handle it, to not ever have this drop in frame rate.
So how was now, from my point of view, and now with the recent years, especially with since .NET or .NET Core, now .NET, that the developer team seems to put a lot of focus on performance. And there is every year, this is like my favorite article. It takes me.
It's always like 7 times faster than before, and you're like, what?
Yes.
Yeah. So our trick back then was we didn't use any of that. Like basically anything that was slow, we just didn't use it. Like it's kind of obvious now in retrospect. But basically we were profiling the performance of the game every day. And whenever we used any feature, like let's say Link came out or something, I think Link didn't exist, but there was some library and some generic stuff maybe was introduced, and we tried it out and it was so slow, we just didn't use it. So basically many lines of the code is just duplicated shit. Like collections, for example, for every stupid type, we had to do one collection. Like there was an int list, a string list, a float list, a double list, a short list, a long list. And basically the same code, we just copy pasted like 20 times. I think back then I had like my first intern, and that was his job. Like get all these classes, like do this, and that like many lines of code. And nowadays, obviously, it's much better to choose like generics, and you get way better like performance improvements from link queries, and internally like string buffers is crazy how much stuff they could optimize inside of like HTTP client, for example. There's lots of crazy optimizations, and anything that uses lots of memory. It's much faster.
Because it seems to me since .NET Core performance is like very important, and all this web benchmarks and so on. And every year I'm looking forward to the article of
that's a really good one. Like look at the size of the article.
This always takes me like several days to read and, and partially comprehend everything. This is amazing, and I'm already looking forward for the .NET 7 edition.
That one is really good. I shared it also on the team, and everyone was reading it like for hours. It took forever. And I don't think anyone got like most of it. It's like really high level. There's also one for .NET 3 and for .NET 5, by the way. They're not as long, but also very good to read. They're basically helping you to get an idea. Whenever I have a performance problem, I need to do some kind of benchmark. And nowadays, everyone uses benchmark.net. I guess you guys used it as well.
Oh, it's awesome.
Yeah, it's very good. But back then, you just wrote your own. Like basically, it's very easy. You just make a stopwatch, start it, do some code, stop it, and then console write line out what happened. But nowadays, you can make it a bit more automated. And back then, we even wrote like a profiler that basically goes to every single function you ever call. And then at every begin of the function, it was calling the start, and then end of the function, the end. And the end, you had like a nice graph, like a tree, basically, with all the calls. And like it was live on the screen. Like while you're running the game, you saw like a tree of everything that was slow. And then obviously you saw like a big red bar at like render or something, or swap screen. And then you went into that function and tried to make it as fast as possible.
So WebSling in the chat mentioned they started with Python, and then Benjamin, you apparently pulled them to the dark side. I assume,
to the good side, to the
dark theme side, but that would be more of an editor thing.
I think Python is the dark side.
You mentioned generics. Perhaps Hendrik, what is over your like scope on .NET and C#, since C# is the language we are using the most. What is your favorite feature that you couldn't live without anymore? Like there is no way going back to an earlier point.
That's a tough question. I mean, there are many features, but like if I had to choose one, I really like expression bodies, but it's not really that I couldn't live with them anymore. It's just because they make the code way much readable. I don't know. In general, I think all the last features or performance optimization features we got regarding non-allocating memory are really impressive. Like you have only your stack allocations and you don't need to do any more heap allocations like the span stuff and memory stuff. This is really interesting stuff. But unfortunately, from the most projects I'm working on, I cannot really make use of it. So it's a bit of a dead end there because most enterprise products they don't really care about performance. So I think that's the biggest difference to game development. Like enterprise, they don't care. They just buy bigger hardware if it's slow. So that's their solution to this problem.
Well, when moving then in the cloud, this would then make a bigger sum at the end of the build.
Of course, Linux support. I totally forgot it. Linux support is the biggest.
That's probably the biggest one to even enable like.
It was too obvious for me right now, but yes, Linux. It's not obvious if you are using .NET Framework. It was Windows only. Now you can use Linux.
Also, I think like all of the performance improvements, like 90% under the hood. So it's like stuff you don't think about, like it's some mass like apps function or like dividing like two doubles and you don't even think about it, but internally it does some crazy optimization now and uses like the newest features of the CPUs and everything gets a tiny bit faster. Like you don't notice it because it only gets like 30% faster here, 20% here. And then every year they add like more stuff like that. And
yes, especially with the new direct hardware intrinsic features, it's crazy what you can do. It's like, it almost feels like C again when you can do like all the low level assembly functions, but in a safe managed way. It's like it's combining the best of both worlds.
Did you guys use read-only memory? It's like one of the best optimizations to work on any kind of stream. Do you know what it is? Or should I explain?
I know the concept, but as I said, I could not really make use of it.
So I think it was the biggest addition in .NET 3, I think 2 years ago. Performance-wise, basically, it's like a struct that hovers over your block of data. So it could be a big string, like let's say you have a website, it's a lot of HTML. And normally you don't need all the HTML at the same time. It's much better if you just say, oh, let's get the head. And then you just make a new read-only span or read-only memory of the block that you care about. You kind of know text starts here, ends here. And then you say, in this memory block, that's my stuff I want to like investigate in. And basically it could make your loading code, let's say you have JSON or CSV file or HTML file, XML, you can make it many times faster. It can be 10 times, 100 times faster just by using this trick of taking like a block of memory out, and it doesn't allocate anything. It's more like how you would do it as a C++ programmer, where you just have a huge block of memory, like somewhere in like the main memory, and then you just have like pointers randomly pointing into it, and do crazy stuff. And now you can kind of do the same in C#. And I really like that. But yeah, I think we used it once or twice. It's like really cool, but it's not many times where you have like this crazy optimization need. I think we implemented it some time ago to the JSON. JSON loading is really slow. It's really annoying if you have lots of JSON data. I don't know, what kind of data formats do you usually use when you have some data that's JSON coming in? JSON as well?
Most likely, yeah.
And we have a lot of SOAP services and stuff like that. So.
XML stuff. And is it slow or is it okay?
For XML, it's depending on the documents, it's rather slow, but in my experience, if you're using JSON and you are using the new system text JSON, it's really fast.
Yeah, it's much better. That's one of the optimizations where they internally used like these tricks I just explained. And if you just use it, it makes everything faster, which is cool. But for us, it was still a big problem because we had some unit tests where we just load like gigabytes of like JSON data. And every time the unit test starts, it took like 10 seconds to read it. And then we try to make it faster and faster and faster as usual. That's what we always try to do. And then we used kind of these tricks as well. And in the end, it was just a big memory block. We just read it and basically not parse it. The trick is not parsing it and just lazily waiting until someone needs like a specific entry. And then you parse the entry. And then you save like 10 times performance or something.
Yeah, I think the trick why system text JSON could be so fast is if you're using this forward reading only parser, which doesn't allow you to do random seeks, but you can just start from the top and then read down. It's really fast because you don't need to allocate it.
And we even
the most important feature.
Like
Sorry?
you can do the same from the end of the file, because sometimes at the end of the file is the latest entry, and you just basically backwards read the file and you start at the bottom and just read to the top and just use this memory stream. And it's really cool because we usually take the last data and the first data is not displayed. And then we don't know how much we have to load. So we just load until we have everything loaded that we need for the algorithm or what the user sees on the screen, and then we stop. And that might be 10% at the end of the stream. But if you would start at the beginning, you would lose all the time because you load all the entries that you later like don't even show.
Yes. But I think I now have the definitive answer to what is the best feature I wouldn't miss and I couldn't live with it anymore. Apart from generics, it's just the task library, async await.
Async. I would say async as well. It's my top thing as well.
That was added in C# 5, is that right? I'm kind of mixing up all the numbers now.
Or was it 3.0? No, I think it was.
It was already in .NET 4.
Yeah, 4.
Yeah. But it took a long time. Like a link was already added in .NET 2, but completely unusable till like 10 years later, till all the functions existed. In the beginning, like you could only do like basic stuff, and everyone still used like this SQL syntax, which no one ever uses anymore. Like basically you try to write SQL code inside of C# and had like 2 different programming languages. It's really strange. And nowadays everyone just says dot and then everything that they want to do, like first filter it out, then select it, and then convert it to something else, and much better.
You mentioned link, so actually I learned this just recently, like 2 years ago, after using async await and the TPL for years, that the implementation of the code is very, very similar to the link implementation.
Yes.
Having the state machine and a lot of switch cases actually, and I think I now understand it, perhaps 50% of it.
Yeah, it's very big. Like no one can know everything of .NET anymore. It's just too many things. Like look at the NuGet libraries. Like it's crazy. It's like millions of libraries, and no one can know all this stuff.
It's really, the community is like, there's so many contributors, and Microsoft Teams seems to growing as well. There is Blazor, Xamarin now evolving into Maui, ASP.NET Core, Entity Framework. I now mentioned just what pops in my head. We could and all of the community libraries when it comes to testing, benchmarking.
Yeah, maybe we can just talk about the favorite library in each, like the categories, like favorite testing library, favorite UI library, what we like, what we hate, or something like that.
I would just quickly ask you something else as a follow-up to this question. What do you think is the most useless feature ever added to .NET?
Ooh, there's a lot. Half of the core library completely useless. I think 80% of it is like almost never used. Like the thing, you can test it if you have a Blazor app, and you basically it adds like the .NET and .NET IO and all this basic data, like data, for example, is like mostly useless stuff. And then you build your website, you have like 20 megabytes of DLL files, which are converted to JavaScript WebAssembly. And then if you do the release build, it goes down to like 80 kilobytes. So almost all of it is not used in your code. Like in theory, you could use it and could write some code, but almost all of it you will never need. But you don't know which part, like someone might need it. So that's why it's all there.
Yeah, the backwards compatibility is quite
exactly. And Microsoft never deletes anything, so it's all still there.
Yeah, they can.
They cannot, exactly. It's too long and too big.
I mean, they made a lot of breaking changes now with .NET Core and starting with .NET 3, I guess. But
yeah, the conversion
there
to
is
.NET
still
Core
a lot
was
backwards compatibility, especially when I ported some big enterprise applications to .NET Core. It was surprisingly easy. Because most of the stuff just didn't work out of the box. Even stuff like WPF and Telerik control, you just replace it. There were some changes in the namespace, but apart from this, it's you just recompile it. It worked. It was crazy.
Because last month we used the code base of Soulcraft, which was written 10 years ago, like an early version of the data engine. And everything was like .NET 2 and like a bit of .NET 4, but no link, no new features. And one guy tried to convert it to .NET 6, which was like a huge jump in, like everything is different. And ReSharper is like suggesting everything in Visual Studio 2022 is like saying do this, do that. But the old code like is so different. It kind of like you can just autocorrect everything, but the whole code that comes out is like useless. So in the end, we just stopped and said like, no, let's stick with .NET 4. Also, Xamarin stopped working, so let's keep the old shit working and just update the libraries basically, and just use the newest libraries. And the good thing is like it doesn't matter. You can use the newest library, but still the code is still using .NET 4. Like it's not a problem. But yeah, it's very hard to update old code. Like the original code I wrote for Arena was like, I would not like to touch it and try to update it. Because let's say you don't have generics, now you have generics. That's a crazy amount of work you have to do to change all the little parts where you before had your own class, now you use a different class with generics, and you will probably introduce many bugs. There's no unit tests, so bad idea. So I would only touch code bases where I have like good coverage, good unit tests.
Ooh, now this I would use as a segue to answer also Hendrik's question about the favorite testing tools. And so, yeah, so Benjamin, you actually, when I started with .NET, you evangelized me. Maybe the term is radicalized me into TDD. Yeah, now I can't live without it anymore.
No other way.
And so my favorite combination is actually don't care so much about the testing framework per se, because I rarely use the assertion part of it anymore. So I kind of start with XUnit, but either one is fine. The attributes are very similar. For the assertions, I currently use Fluent assertions. And then I create my test coverage with coverlet plus report generator, and mutation testing with striker.net. So this is my testing tool set. And then from an IDE point of view, if I use Rider, Rider, I really like the continuous testing. So then it shows me in the gutter little green arrows when little green indicators or red indicators, or hopefully never gray indicators when the test is passing, failing, or not covered by that line.
But you have to compile it and run it like.
Yes. So I think in the background, when I save the file, it's compiled.
So it takes some seconds. Yeah.
I think only the impacted tests are run. So indeed, it takes some seconds. Yeah.
That's the thing about nCrunch. It's like so fast, you don't even see it. Like it's happening 10 times per second, and it's crazy fast. And if it would not be fast, it would be useless tool.
I haven't used nCrunch I used the Delta engine, so that's more than 8 years ago. I haven't used it ever since. But back then, also I haven't really appreciated. I was a beginner in the field. Now with almost 10 years of .NET experience, I would tell past Stefan a story if I get to meet him.
Yeah, so NUnit actually came out in the very beginning, like when .NET came out in the same year. But I think I was not really aware of it. I think I used it like and said like, this is stupid. Like I can just write my own 10 lines for unit testing and just build my own assert class, and like it's like one function I equal, and that's it. So like you don't need much code for that. But then later I used it a lot. I think 2005. I think the other ones didn't really exist yet. And then I think from 2008 to 2012, I used XUnit mostly. But yeah, it was like the thing that was cool back then. And then said like everyone is using NUnit. I think it has still like many million downloads. Let's check it. It has in total, is there like a total number? Yeah, 160 million downloads. So that's by far the most successful, biggest test unit framework for .NET. It's similar to like JSON. Just use JSON. Like it's a top.
Newtons of JSON?
Newtons of JSON. It's a top one that has like 1.6 billion downloads. So
yeah, but I think it's just because with the open sourcing of the .NET runtime and library, Microsoft was using for some reason XUnit, and then everyone else is also using it. I think for a long time, if you make like a new testing framework using .NET UTest, there was only XUnit. I think it's just a couple of years that you can also use like NUnit and MS Test.
Mm-hmm.
Oh, MS Test also has 120 million downloads. Holy shit! So because it was the default, basically, yeah. So I guess
a lot of people use it. I mean, like the current code base I'm working on, they were using MS Test, and now with Switch.NET Core, what do you do? Like the old MS Test doesn't exist anymore. So obviously you have to use the new open source version MS Test V2, which isn't really better, but it just works as a drop-in replacement.
Yeah.
And
so I guess all tools should support at least like NUnit, XUnit, MS test, and then MS test is like phasing out because it's not really working anymore.
It's just legacy.
Yeah.
Is it still? Are there still updates to MS test?
The NUGAT package is still here. Like it's updated 3 days ago. So.
But I don't see any reason to use it for a new project.
But if you look at the download numbers, like it was huge. Like versions had like 20 to 50 million downloads, and now the latest version is like 200,000, and it's slowly like dying. So you can even see in the download numbers because it's not longer the default. Like it's not happening as much anymore. But let's maybe talk about testing in general, like because 10 years ago no one was doing any testing. And now it feels like everyone at least knows
now no
testing.
one is doing testing either.
Yeah, now no one is doing it correctly, but at least everyone knows there is testing and it's kind of important.
Everyone claims to do testing. Yes, yeah, that's maybe true.
Yeah. So, how does it work in your teams? Like, is everyone doing testing, or you're the leader guy that tells them to do it correctly, or is everyone on board?
I think the best case you can have, if people are writing tests on a regular basis, they are mostly doing it after the facts. So they write their code and then they like creating some tests to get some coverage or get some confidence. But I think it is only a minority of people who are really doing test-driven development and actually understanding why you should do it. At least in my experience, like I would say like 80% of people don't care. Maybe like 10% occasionally writing tests, but most people don't care. I do not really understand why, because if you talk with them, they are like, yeah, why should I write tests? I'm a good programmer, you know, I don't make mistakes. And and it's costing time, you know.
Never.
I never get this time to write a test, and they somehow see it like as a completely separated task. It has nothing to do with the implementation of the business logic. Like testing is something, you know, QA is doing it or whoever.
But then it sounds more like a cultural problem. The company structure doesn't really support like.
I don't really know if it's related to the company culture, because I think if
the boss, like in my company, I'm the boss and I'm telling everyone I have to do it. In the beginning, everyone's like saying the same arguments as you, but after like 2-3 months, everyone is doing test-driven development every day. And from time to time, like currently we're doing research on like crazy, like figuring out which way an object is pointing in 3D. And everyone is doing like crazy, like I'm using Python, here's like I'm using some library here, I'm using some Azure and I'm using some cloud thingy, and everything is hacked and there's no good unit test. And then I come back in and say, now it's the time, research time is over. Now go back to production code and now start with the test.
You are a very tech-savvy person, and in most companies, management people have no idea about tech stuff, and they shouldn't know about it. Like they have other stuff.
It should be in the development team.
That's so it's fine, but then there is no one enforcing it, and given that with the fact that most people don't care about it, no one is doing it. So you have to be very lucky to be in a team where most of the people think this is very important, and then they will do it automatically. But most of the time, this is not true. Like they don't care; they just hack their code. And
how is it in your team, Stefan?
It's I have the impression most of the developers, since we have multiple teams, I get to view most of the PRs, not most, many of the PRs. Seems to be, to me, after the fact, but some really do it. Was the opposite before the fact? Actually, equality is writing in the chat. By the way, thank you everybody for tuning in live. That it seems that developers are told to do testing, and in a after the fact manner. This is what they got told to. Okay, so you have not a test, you have not a code, or at least how I read the message. Yeah. Here you got now the production code. Before you check it in, we need coverage, otherwise maybe CI will fail.
Yeah, that's a good point. Like if you enforce it somewhere there, then they will do it after the fact. But it's still not test-driven development. It's like they still didn't get it there yet. I think it's very close. It's only like one step further and then you have it. Because you're using already the tools, you know what to do. You just have to like change the order you do stuff.
So it seems to be a lot about Well, at least to me, from my experience, I had a great mentor. I would not wonder if Benjamin, if I wouldn't have met you in my early days, how would I do TDD now? How would be my stance?
Yeah, isn't that sad? Like, shouldn't everyone like learn it in school? Like, you should have like some Uncle Bob guy that just explains people they want to do programming. Just tell them like, hey guys, do it like this. And that's kind of like a doctor learns like stuff from all the learnings from the last like 500 years. And you cannot just have your own opinion. You wash your fucking hands before you do any operation. That's the order stuff is being done. And if someone figures out you're not doing it, obviously, then you're in big trouble. And I think the same is not happening in like new stuff, like in any programming language. Everyone is just doing cowboy style, bam, 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 and do whatever they want. And then even saying like, I'm the best, I'm killing everyone. And that's like really bullshit. And it has to be more professional. Like it won't happen overnight, but I think maybe in 20 more years, like there.
Yes, I think it's already
more strict.
Partially happening, but I think the biggest problem there is if you go to university and you study computer science, you don't learn to code. Like you learn all the crazy concepts, how a computer works and how compiler works, and
you learn everything.
All this crazy shit you will never need writing any boring business application. I think there are already some courses which are more like actually software engineering, like studies where you learn how to code properly. But most of the time, people who want to code professional make a computer science degree, but then they don't know how to code. So
they don't have the experience,
and then they start from scratch, basically. I mean, I've seen a lot of people coming fresh from university who have absolutely no idea how to properly code. It's just
when
crazy.
I hire someone, I always want to see some code, and I prefer that 10 times over any degree. Like if someone has written the last 3 years, like programs, I can see like websites that work, and like he's showing me some code, he's did this or that and can explain it. It's way more useful, especially if he did all the steps like designing, writing it, having all the problems, fixing all the bugs, having some customers that use it and then complain like it doesn't work, and doing all this. That helps enormously when you next time have a problem, because you already have in your head like an idea how to approach the problem. If you're just coming from university, you just like basically you're in pure research mode. You're just randomly hacking around like a hacker, like in a movie with a hood on, and just bam, bam, bam. And you might be fast, and in some areas you might be good, but it's not really good production quality.
It's not sustainable. You cannot maintain it.
Like you and that's the main problem I also have in game development, because game development is 90% of that. It's just people like, I have some idea, hacky, and then, oh, Unity does provide me like with 80% what I need, and just download this, put this here, and do the spaghetti code here. And it works fine for like a week, like for like hacking up something. But then you have like a big project that takes many years, and then the problem comes. And
yes, but also the problem is that most companies will promote this kind of persons because they deliver very quickly. Like from management point of view, it's like, oh, this guy like solved this task like in half a day, and the other guy,
took longer.
I don't know, like took 3 days.
Yeah,
and
even though the 3-day guy is
time to market is king, so obviously they will choose the quick solution. But yeah, now like if you have to maintain this product for 10 years or more, then you are in trouble.
But I think that happens all in all of software development. Like if you look at Facebook, it was just some random stuff that Mark Zuckerberg hacked up in PHP. There's not a single line left of that. Like everything was rewritten like 3 times over. It's all like C++ code now, and it's very different. And like no one would like think that the original idea and the original code was any useful. But they hacked something up, made it work, and then the community came, and then they said, okay, now we have the problem. We have to spend like 10 times more money to develop it properly, but doesn't matter. We have 100 times more money, so no problem. And I think that's how many people think. Like, let's do a shitty job first. If it's successful, we can still clean it up.
But most of the time, the cleanup will never happen.
Yeah,
I mean,
most companies are not Facebook, not as successful.
You have these big companies which basically have infinite money, like Google, Facebook, Microsoft.
Yeah,
and of course they can write only code, because if it sucks, they just throw it away and create it new from scratch.
20 more people.
But like 90% of all the other companies who exist and maybe just have like 4 or 5 developers, they cannot do it. They have to maintain their product, and if they screw up in the beginning, they will not survive probably, because if a competitor comes around like a few years later, with a much better product, they can never catch up. It's just impossible. But I think most people don't see this. It's just.
Yeah, it's a very good point. I think you can see it in game development. 80% of companies go bankrupt before the first game is like released or after the first game is released, because like half of them don't even finish the game. They go just bankrupt before they even do anything. And then even the ones that get successful, most of them are still bankrupt because the product didn't succeed. And like you could not do the same stuff again, because everything you have to throw in the toilet and start over. And some of them are obviously successful and make lots of money, and then they fix a problem later, which I still think is like a strange way to approach it. Like you wouldn't build first like a shitty car out of wood and then like drive it and it falls apart and then try it again. Let's build it out of plastic. And then like 10 years later, you have finally a metal car. Why not design it properly first? Like it takes longer, yes, but then you will for sure have a much better product in the end.
That's the cool thing about software. You can change.
It's
stuff.
easier, yeah.
Obviously,
you can iterate and change stuff, and not just yeah.
And people don't see immediately how crappy it is, because it's just an abstract virtual thingy.
And like you could put nice paint on a shitty job, like no one knows.
Yeah. If people would build physical products in the same way most build software, you would see it immediately that it's trash. But with software,
you could not even sell it. Like
they create a shiny interface for it, and then they are good to go.
I think China is a good example. Like they produce so much shitty products and stuff that falls apart, which is cheaper, which short term works really good. Like make lots of money, lots of exporting. But long term, everyone will say like, oh, we need like a thing here, like a motor. And then if someone says we need one that doesn't break, then no one in the right mind would say, let's go to China. Use the China quality one that was cheap. You always will say, no, we now need a quality product. And I think long term, that's where it ends up anyways. It just takes time. So I guess 20 years are not enough.
Well, I guess it wouldn't be so. The excuse of a lack of tooling wouldn't count in the .NET world.
Yeah, it's the best tools in the world by far.
And I think it has nothing to do with .NET. It's just a general problem in the industry.
So more of a cultural mentoring. Maybe Webslinger writes they also learned TDD at the Delta Engine. We had the same master.
Did we talk about other tools? Like you mentioned, like Rider, which you like, which is very similar to Visual Studio. It's basically just Visual Studio plus ReSharper in one thing.
It's like IntelliJ for .NET.
Yeah, it's like IntelliJ. So it's very similar to what Henrik and me are using. But the main disadvantage is like the advantage works on like other platforms, and it's like not just Microsoft stuff.
Yeah,
if you want to use, it doesn't have the plugins.
Yes, I just want to add, if you want to do serious development under a non-Windows system, is basically the only choice you have.
Yeah, there was Xamarin Studio,
Visual Studio Code, but it's
it's
not, you cannot use it seriously for any project.
But on Mac there was like Visual Studio for Mac, which came from Xamarin Studio. So I think that for a few years was like kind of okay. At least you could do like iOS development with it. But I think Rider is now way better than it. So I guess people just use Rider for that now.
Yes.
Maybe it's also a question of preference, since Henrik, I see it a little bit different. I also actually know a person who mainly codes in VS Code, and I couldn't claim they are less efficient than I would be with all the fancy pants tools. Perhaps it's just a matter of practice and
no. You can compare 10 developers, and if they use a proper tool like IntelliJ, Visual Studio, like if they're good developer, like obviously if you take like a 5-year-old and put him in front of Visual Studio, it doesn't matter, he doesn't understand it. But someone that used it like for 10 years is by far more productive than anyone using any other IDE. Like if you have a good IDE, like IntelliJ is good, ReSharper, Rider, Visual Studio, they have like so many things and so many tools and so many things that make your life easy. Like a good example is you just want to build like a program that has some visual stuff, like a website or like a Windows Forms, WPF, Maui, whatever, and you have some editor, and the editor allows you to just drag stuff in, and it's visually, you know what to do, like you know the toolbox, drag stuff. In 10 minutes you have a working app. If you do the same in a console, like in a shitty Visual Studio Code or Notepad or something, or use it even in Linux, everyone uses VI and Emacs and all these really horrible editors. It will take years to do the same stuff that the other guy did in 10 minutes. And it's not comparable. It's like completely stupid to think just because the other tool has like some cool shortcuts, it's not comparable to build the same thing. It's like saying I can build in my garage the same that Volkswagen can do in the big factory with like millions of people. Like obviously they can produce a car hundreds of millions of times more efficient than I can do with all the tricks they accumulated over the year. And I think it's just stupid that people still don't get it, that you have to get a proper IDE and a proper computer that's fast, and don't use like a shitty old machine and then say, oh, I like Visual Studio Code because my computer is so slow. Yeah, great. Because Visual Studio Code is just an editor. It's not an IDE. You can make it into an IDE with plugins, but by default it's basically Notepad with some syntax highlighting.
So okay, talking about the out-of-the-box experience, but now I want to put that to the test. Perhaps it also depends on the application model we are using. For example, I recently in private do a lot of stuff with Roslyn, and for the next stream, maybe not for the next stream because I wanted to show wider there, but for coming up stream, I will then try to use VS Code, and let's see, and want to find out for myself how I then
OmniSharp, I guess,
how my experience differs in those three IDs.
Are you using OmniSharp then for?
I would be using OmniSharp, yeah.
Yeah, so basically the plugin, yeah.
And since for Roslyn is also perhaps also circling back to testing a bit, there is also the a nice testing library by Microsoft out. Perhaps off stream we talk briefly about Blazor, and there is BUnit. I love BUnit; it's amazing. And perhaps also with combination with Playwright, with a more of an
it's just for Blazor, yeah.
More E2E experience. So there's a lot of testing tools, and maybe with the right plugins, perhaps you can have a similar experience on every system. But I'm gonna put that to the test.
So I think we talked a lot about IDEs and tools, like maybe nCrunch we mentioned a bit. So by far, I think it's the most important plugin if you're doing test-driven development. If you don't doing it, it's completely useless. Then it's probably continuous integration, like maybe you guys use like Azure DevOps or TeamCity or Jenkins. I think it's very important to have it. And once you have it, I think it forces everyone in the same, like you have to do it properly. And I think it helps a lot with professionalism, because if you don't have it and everyone just commits random stuff, you have a mess of spaghetti. But if you have like some guidelines and say only this kind of code you can check in, it makes everyone behave better. It's like,
it especially works better if a machine is gelling at you that you produce shit code instead of another human gelling at you while you produce such shit code.
But the analyzer, which is telling you, there was an analyzer or some other tool which tells you this is bad, has eventually also been written by a human with some sort of opinion.
How do you blame him? You don't know him.
So is there,
you don't know him. It's just a policy you violated, and it's way better than someone writing manually in review that this is bad.
I know this. I just say like this basic rules basically come from like the tool, or like Uncle Bob said it. And then obviously I put some stuff on top of it, but the basic stuff already gives me 80% of it's not my fault. Like just do it the way the tool basically says it.
The computer says so, so do it.
Like if you just install ReSharper and look at any source code, it will show you all the issues. Like it's not like me or Hendrik or anyone like complaining. It's just the default setting of ReSharper will just say this is not the right way to do it. Like there's a hint here, do this. There's a warning here, do it this. And this is an error. Like you're doing it wrong here completely. And then you just press Alt-Enter a few times and then the code is good.
Hendrik, may I paraphrase you or try to quote you? I think a couple of years ago you told me, I don't know what I'm doing. I'm writing some code and then hit Alt-Enter until everything is working.
Alt-Enter pattern, yes.
Okay, cool. Then unit testing we talked about a lot, like test-driven development, clean code, Uncle Bob. Yeah. So Uncle Bob has lots of books, maybe.
Yes. Talk about. Perhaps before we jump to that, one thing I would like to add, since we talked about tooling and CI, what I love is, which has been added in .NET Core 3 or 3.1, local tools or global/local tools. So you can have .NET tools as part of the repository, which is backed by some NuGet package. And then locally, you can have the same version of the tool as the CI system and then make, have the similar experience then, or at least get the same
kind of mini Docker in the command line?
Something.
I think it's mostly useful for continuous integration environments. I'm not really sure, because apart from there, I've never really used
But
it.
is there a solution to it? Because versioning is always hell. Like .NET, the YouTube channel just had like a podcast about it, like 2 hours. They talked about versioning, and they just said it's impossible to solve, and .NET will never solve it, and it's like fantasy. But there's like things we can do to improve it, basically. Because yesterday I just had the problem. I have locally on my computer just updated my Visual Studio. Didn't even think about it. Just started it, stopped it, and then I had the new version. And in the background, it installed .NET 6.0.2, the newest version. And in that folder, there's like a Windows Forms Integration DLL file, which is in one of my projects referenced. And I didn't think about it. It's fine. It's just update the reference. It works. Just publish it. And then it was on the CI server. CI server was still on the version prior to that. And it didn't find the path. Like the folder was not there. The file was not there. And the whole CI build just failed. And I was like, what? Why is it failing? I still using .NET 6. The server is .NET 6. But it's not that easy because .NET 6.0.2 is different from .NET 6.0.1.
Yes, but it's actually a solved problem. You can pin your SDK version in your global JSON to a specific version.
No, it will deinstall the old one because the old one had a bug.
But you can install arbitrary versions in parallel. Actually, never had this
not with the .NET security. It's like a security patch. And it only affects the DLLs that are not NuGet packages and not like normal assemblies. It's like some kind of helper assembly bullshit thing, which almost no one ever uses. So we only have this problem in our WPF connection from the engine into the WPF world and back, and no one else like has this kind of problem. But in that thing, we need this Windows Form Integration DLL, and we always drag it along from every version we have it. And this is really stupid, annoying bug. But also like things could happen, like you just say NuGet update everything, and then all your packages are fresh, and then someone removes some function that you used, or like change the class name or something. It rarely happens, but in theory, when it happens, you're all stuck. Like either you have to like revert back to some old version that works, or like it's a horrible mess. Like versioning is always difficult.
So I hope everybody is adhering to semantic versioning so that we know when there was a breaking change.
Yeah. So if a major version, I would always assume there's something broken. Like if I'm going from .NET 5 to 6, actually it was really good this time, but I would assume like something will change and I have to check at least some parts. But if there's like a .NET 0.1 to .NET 0.2, I don't expect like everything to break. But yeah, yesterday it just broke, and
that's interesting. Yeah, I mean, I had similar problems in the past, but since we start pinning our SDK version to a specific version and also with no roll forward policy, so you have to use exactly this version.
Yeah, that's good. Yeah, but we want to stay up to date, so it's still like
of course, but you want to do it when you want to upgrade it, not when some random version decided, some random person decided to install a new version and everything goes hayway. So
it was just annoying because it happened automatically when I opened Visual Studio and I closed it, and it was just installing the new version. I said like, hey, good. And
you don't want this.
Yeah, normally you don't want it. Actually, there's also C# 11, like some early stuff coming out. It's interesting.
Yes, it is.
But that again, like I was trying it out yesterday, like the newest EAP from ReSharper, and then the Visual Studio preview version, and then the C# 11, and everything is a mess. Like nothing works together correctly, and just have to wait a few months. So it's very hard to live on the bleeding edge. And every week something changes and breaks your code, so it's not that much fun.
I today had a look at the new exclamation point. Actually, not sure about the
horrible syntax.
This is currently a really heated discussion.
Yeah.
But I had a look at it, how this feature works and what code is generated. And actually, I've been awaiting this since, to use a C# term, awaiting. Okay, since C# 9. I think there was a talk by Mats Torgersen, who then briefly teased that operator for C# 9. So, but then it was postponed.
Can
but
you
it's okay. It's just
explain what exactly it's doing. I've never
perhaps
heard about it.
If I briefly share the screen.
So everyone, I guess, knows a question mark, especially question mark equals.
Yes.
And it's just merging lots of code into like one thing. And I think the exclamation does like similar shit.
I think like the only feature I'm really pumped for C# 11 is the possibility that you can finally use generics and attributes.
Yeah,
So instead of type of, you can use generics, which makes
I tested it yesterday. ReSharper already has it. It's even suggesting it, like use a generic here, and it works pretty good. Like ReSharper can do it with
That's a good feature.
Yeah, it's a very easy feature. I don't know what the big problem was with that one.
People asking it for decades now. If you look at Stack Overflow, like 10 years ago, people requested it.
So this is basically what the exclamation point feature is doing, is it's adding a null check, but a very efficient one, because if I would be, or so far I did null checks like I just commented here, similar to if a, so with the discard, the standalone discard pattern, I say like if a is 0, then throw, oops, come on.
Typing is
argument null exception. Okay, type in here, but like this. But the advantage now of the exclamation point is that it actually creates a method. It's some unspeakable method that we cannot use in our source. But since it's hidden in a different method, now this method that I have up here is now still eligible for JIT inlining. So that's kind of cool. And also in .NET 6, this was actually added in .NET 6. So there is now on the argument null exception, there is now a throw if null method, which is basically pretty much the same, or is it almost the very same as the code which is generated. Yeah. And now I even save this line.
Yeah, but in my code base, I never use this line of code, so I think it's not a good idea.
So is it well, if it's an internal code base, I guess then with
in general, like even if I make an API, I should be very clear that, let's say I'm nullable, so we enable nullable in the project.
Yes.
For C#, and then every single type that I have that says I'm a string has to be a string. There's no way it could ever be null. And if I say I want a string question mark, then it might be null, and then I have to check, like in case the user gave me null to this, but it's not an error. Like if I say give me a string question mark, you're allowed to give me a null, or you can give me an actual string. But why would I like allow him to give me a string and then double check if it's null? Like what the fuck?
And then throw, and then the caller has to catch it again. Like what problem are they trying to solve?
Well,
I don't understand.
If it's a public method that you have in a library, for example, distributed via NuGet, you don't know if the consumer of that library has nullable enabled.
So that's what I'm saying. Like if your library just says I have nullable, and then your user doesn't use it, then he gets all kinds of errors and exceptions. But in case he uses nullable and properly looks at, oh, this type is like, I have to give it a proper type, you get like a compiler error anyways, then like you don't need any of this code. Like it makes it completely useless. And like back to the test-driven development, if I'm writing a test, in my test, I will tell the function what to do. And then there's no way I would ever write a test where I randomly pass in some null and something that's not supposed to be null. So it would never happen with test-driven development. That's kind of my point.
Well, that's right. But I guess for me, how I like to in public libraries still check for null if this is, especially if this is in an async method or in an iterator method, because then this null reference exception may happen when later when it's iterated.
Yeah, it's harder to read. You're right,
so I kind of like the immediate throw argument null exception, which says you shouldn't have passed, and then it also says nicely the name of the argument, so it's very then.
So error checking is very important. So I'm currently writing combinational parser, and the thing is, the earlier I detect there's something wrong and like provide a nice error message, the whole like compiler gets way easier, because if I can basically say all the input that comes from whatever is like already checked and went through X steps of like validation that all of it makes sense, then in the end, the actual expression parser or something is like one line of code. So if you guys want to see, I have it on my screen. I can share it.
Yes, please.
I can talk about some code.
Yes, that's what I'm here for.
Nice. So let's just share Visual Studio. So I don't know if it's nicely visible. In full HD should work, but I can zoom in a bit.
Yes, please zoom in a little.
Crisp and clear.
Crisp and clear, nice. So let's say I have like...
if you mind zooming in a little bit more, at least in the text.
More even, great.
Yes.
Okay.
Thank you.
Okay, so let's say this is like my strict compiler project. So I have like expressions here. So that's everything the language can do. It's very simple. It doesn't have many keywords. You can see here, like I only have like a bunch of like expressions. Some of them are still missing. Like I think the link kind of support, which we do more like Haskell, will be here, which is very complicated. So that's why it's not here. And this is like the basic structure of the like what the language can do. It's not much. Like the whole code base is like 1,000 lines of code. It's not much, but it can do everything already. And you see here, like when I want to write like my like different classes, like doesn't matter which one. Let's take if. It's maybe easier to explain. And so usually I use two tabs. On my right side, I have my tests usually, and on the left side I have the code, and then on the other monitor I have some Netflix watching when it's boring. And mostly I'm focusing here. I'm looking basically here and writing some code. Usually it doesn't start like simple as this. Usually I have like, so this, we like all alt enter. So we have some parse expressions. So maybe this one was like a complicated thing as well. And then this one, make us happy. But maybe I had some initialization code here, like, I don't know. Oops. Autocomplete is not always useful. I know something. So yeah, stop complaining. It's an argument. One of these doesn't matter. Okay, and then I have some logic here and expression this one, and then I do something with it, return it, and then I figure out, oh fuck, this doesn't work. Like in this case, basically what I'm checking, if I just have like an if statement, but there's nothing coming behind it, then that's bad. Like I'm missing something. This is usually when you here in C# just write if, and then you stop writing, you get like obviously a compiler syntax error here, and just says I'm expecting opening bracket because I'm C#. And in this language, there's no bracket, so I basically have to check all the other words that come and see if they make sense, or like is it an expression or not. But if nothing comes, then it's an error. And like in the end, when everything is like optimized, then you have like a single line like this. You can see I always have like failure conditions. A lot of it could go wrong this way, that way, and so on. And that's basically similar to the thing you talked about, where you first want to check if the user gives you the correct input and like fail early and not like go all the way to the end and then the end crash at some random point and you'll be all confused. And similar here, like as we see, this one basically calls the parse expression. It's like a helper thing for the test, which basically just takes a bunch of code, like many test uses. So it's like its own little testing framework, I would say, for testing expressions. You can see here all kinds of like things are pre-created for you. And then here basically what it does when it's all like good, it puts it in a new method, in a method body, and just puts the code that you gave it in the unit test into the new method and just runs this method. And because that's the only way you can check if it's working. And then when it's working, you get the expression out. If there's multiple expression, that's a problem because we are only supposed to have one expression. And if it's like no expression, that's also bad. But normally it would go here. And then if we check this one, that's a method body, which is a lazy thingy. So we have to go to the value. And then you can see here, it uses some parser. And then the parser here goes to this abstract class. And oops, that was wrong. And the abstract class is implemented here in the method parser. And then this one calls, like it's lots of steps, but basically all of them point here to the parse function. And then the parse function basically just says like, whatever it is, I'm trying it out. Like I'm first trying, it could be an assignment, then, oh, it's not, then let's try it's an if. It's good because we're trying if, and then it does, and then it tries all the other ones. But in our case, it goes to the if one, and that's the whole code. That's the code how to check if it's an if thingy. So if I just have an if, nothing else coming, then I'm missing some condition. That's actually the exception we had on the right side. And if the line starts correctly with the if, and then something else is coming, then I'm going in the helper function to check if it's like valid. And if not, then it's obviously not an if. Like it doesn't start with if, it doesn't have if. So nothing, it has nothing to do with if. So we just like go out of this. That's why it's called try. And then this function, which is a bit more complicated, so you can see here, is it too long? Not good. So like it should be probably less, but almost all of it is error checking. Like first it checks like, is the condition that comes, is it correctly the next line? Then it has to check the next line. If there's a then statement, then, oh, there's no then statement, then missing then exception happens. Then if you forgot your indentation, put it all in the same space. It's like in Python, you have to indent it. Then there's another exception, invalid indentation. And the problem here is like the errors, like because you're very confused, you get the error, like where the fuck is the problem? So you have to give the user everything, like exactly what he wrote, where is it wrong, which line is it, and which word was like the parsing, like at this point was saying this is bad. So you want to give all the context. That's why all this stuff here is passed into the exception. And then, yeah, basically you just pass whatever the then is. You don't know what it is. So you just give it back to the try pass and it will figure it out. And then optionally you could have an else thing. And then the else thing could also fail, but normally it just goes to the else. And then finally it builds the if condition. And the if condition is very easy. It just gets the three things we just passed and just remembers them. And now it has like these expressions. And anyone that's consuming this has to know this could be null because it's optional. Usually I call it optional when it's nullable. And yeah, that's usually how but the code didn't start like the way I explained it. Like I'm cheating because I started with one line of code, pressed Alt Enter, returned something, fine, next one. And after like 5-6 tests, I finally ended up with this code basically. And sometimes in between I got stuck and then I refactored half the code base and took like 2 hours on that. But that's kind of my process that I'm using here. And the cool thing is for compilers, everything is deterministic. So it's like the perfect use case for unit tests. It's much easier than game programming or like websites or apps where you have like some user interface and maybe some people complaining about something and want some different design. It's much more difficult. In a compiler, everything is either correct or incorrect. So that makes like test-driven development it's a really good fit.
In the chat previously, we had a matching comment about always start with a nothing test.
Exactly. So when I teach my people, we always say nothing, and then have this guy, and you can see immediately here NCrunch is jumping into action, and I see immediately I have this working here, this green dot. And we don't start anything before we have this green dot. So you have to install Visual Studio, all your project has to compile. You can see down here, like my Sharper has to correctly work and compile, but it's normally not needed because I'm using here NCrunch. For example, yesterday I noticed I worked like 8 hours or something and never saved. Like I still had the files from the beginning. And when I was going to GitHub and to commit, I was like, whoop, there's nothing to commit. And then, oh, I didn't save. Because all the time I was working with Sharper and didn't care about saving anything. It's really cool.
So this code reminds me very much of Roslyn that I recently now, I think from almost 2 years now.
We have Roslyn right here.
And oh yes, delicious.
There it is. So we have like our connection from our code to generate Roslyn stuff. Currently it's very simple because we just generate some simple code. But yeah, in the future we could do more. But our C# backend is not the solution. It's just like a in-between step because we don't have our own virtual machine yet. So I just hired 2 people. So hopefully they help me and get this finally finished. Because I worked on this like for the last 2 years, but never have time. It's only 1 week work on it, then half a year nothing. So that's not good.
So talking about presenting the user nice error messages as early as possible using Roslyn analyzers or whatever tooling.
That's cool.
Do you always have warnings as errors?
Yes. So you can see in this whole project, there is not a single error, there's not a single warning, and we have 100% coverage. And that's kind of the only way it's allowed. Because at the point of this language, it's even worse. So it doesn't allow you to even put a space anywhere. If you put a space here, you see like, oh, unnecessary white space, not allowed. Bad, bad, bad. And basically it forces you to do some. Even if you make an empty line here in between to separate it, it says like, no, 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 no. We don't like empty lines. And all this kind of rules in the language itself. And obviously I'm doing it in C# as well, because that's the whole point of this, to get like a proper code base where there's only one way to do it and not like this guy likes it this way, this guy likes it this way. So it has to be in a certain way. So everything, even like a hint here is like it stops compiling and the CI system will say, no, I don't like it.
Now looking at this, to me, this is very poetical because now I know where my excessive end of line additional spaces obsession is coming from. I blame you.
Exactly. So basically every project we have looks like this. We always use the latest framework. We have always nullable enabled. So I guess this is a test thingy. So it has this package thing, but then always treat warnings as errors, And for some reason, yeah, this is CUDA. It only works because it's a dependency to the NVIDIA CUDA library, which doesn't work in 32-bit. So it has to be 64-bit. But that's probably like an exception here. It's only in the CUDA project. Every other project doesn't have this.
Since .NET 5, you can also enable the .NET analyzers, which are included in the .NET SDK.
Mm-hmm.
So there is like a property net. Actually, it is enabled per default for,
like
for targeting Net 5. Yeah. Yes, but per default, it's only per default. Not all of the rules are enabled.
Mm-hmm.
So
exactly, you have to go through the thing here. But yes. Since we use ReSharper, like almost all of this is already in C#, and is way better in C# and ReSharper.
Mm.
So, like usually we set up everything here. Like we have the clean code stuff, very good. One of the best plugins for ReSharper. It tells you exactly what like your limits are. Like don't write classes that are horrible and long. Not like Arena was with 50,000 lines of code. And then the cool thing is you can make lots of rules here and lots of like formatting stuff, and it's very good. But it takes a lot of time. Like we have to be honest, like a newbie cannot do this. So you have to have someone that's experienced a few years, plus also this whole setup of using like a CI and stuff like that. It will take many months to get it proper, to have like everything connected. So you need an expert like Hendrik. He's really good at this shit.
Would GitHub Codespaces be a solution for that, so that you just hit? I never used it so far. So hit.
I like it, but it's
white mouse
not
button,
powerful.
New environment, and then kickstart a new member to the team.
I think GitHub in general, all the features in GitHub really nice, really good. Like Codespaces, they have like issues tracker, and they have so many things, but all of it is like really basic. So it's okay if you have a small team and if you have nothing else, like obviously use it. But if you're used to anything else, like if let's say you use Jira, we use Frogbugs, or you have like a Trello board, it's completely useless to have like GitHub as well. Like you have to pick and choose and which one you want to use. And like I think Azure DevOps is pretty big, but I think the GitHub Codespace is not that useful, like maybe for smaller projects. What I really like is this, what's it called? The GitHub thing where you can just click on and see in the browser live a Visual Studio editor.
I think you just need to hit the dot key when you're logged in.
Yeah.
I think it's github.dev. This is amazing.
Open with Visual Studio. They just call it Open with Visual Studio now. So basically, it directly opens it in the browser, and you don't have to download anything. You just in the browser can use Visual Studio Code plus the plugins, but you have to provide a server to run, because the plugins can run like C++ or something, which doesn't work in the browser. So you have to provide a server, which then the users with their Visual Studio Code, doesn't matter if it's from the browser or from like the desktop, and then connect to and then do some services. Let's say your compiler is there. And I really like that.
Cool.
It's really cool. Yeah, but again, it's kind of only making sense for open source. Like in our normal code base, we cannot use this because our normal code base is like top secret. But I like to use it here.
It's so top secret, you just shared it with us.
No,
that's the open source part.
Yeah. So, but it's still very early. I can maybe share it again.
Don't tell it anybody. Okay.
Yeah.
Yeah.
Just talking about this guy. It's like thing. And the feature here we were talking about is like clicking this button basically, like Open Visual Studio, but you can also click, oops, I have to go back, here on, oh, I guess it's not available here, yeah, because the code base is too different. Oh, can I just click here? No. Yeah, whatever. Guess has to be enabled.
The code spaces.
Yeah. So that GitHub is good for open source stuff, I would say. But if for private stuff, we also have a bunch of private assembly like projects. But yeah, it's good to have it, but I would prefer my own tools. It's much more integrated. So, like how example do you merge? Like when you have a merge conflict, someone worked on something, someone else worked on something, they both touched the same file, and good luck merging it with GitHub. It's like the worst horrible merging thing. Like for 30 years, like there's many better tools, and GitHub still uses some command line shitty merging with no default editor. It's just command line mess, pure.
Hendrik, when we were working together, we did a lot of three-way merges, didn't we?
Yes.
But you used Tortoise, I guess, Tortoise SVN and Tortoise HG, or they had like this diff merge, like idiff and I think just diff. I think the name was just diff. But what do you
Actually,
have merging conflicts?
I
Or
don't have much merge conflicts anyway, because I mean, merge conflicts per definition can only happen if two or more people change the same file at the same time. But why is this happening on a normal basis? I mean, most of the time, people working on different subjects, so it's very unlikely that they will change the same file. So that's the reason.
Okay, that sounds strange. So in our code
so
base,
we do not have often merge conflicts. Actually, it's not a big problem.
Okay, so
and even if we have, Git is so good in auto-resolving them that most of the time.
Yeah, most of the time it's not a problem, but when it's a problem, I hate the shitty tools. So we have for every developer, they have their own branch. You can see here, like lots of branches. And at some points you want to merge them back. Mostly we do it automatically. So when it's mergeable and no errors, everything green, and as I just showed you, like everything is working fine, then it gets automatically merged in the default branch and everyone else can just take that, merge with that, and usually there's never a conflict with that. But sometimes people still work on the same shit and then two people have a problem and then you have this merge conflict. And we have it basically on every repository. It's not like only this one. Like even this one here, only one guy worked on it, but then at some point, like multiple people worked on it, like you, that's you here.
Hey, it's me.
Yes. So you worked on this like 5 years ago, and then there was a conflict. Like when we had to merge here, like there was only a tiny issue, I guess, but there was some conflict on some lines we both changed. And then I guess in this case it was not a big issue.
Oh boy!
So I really like the
from
tools.
The past.
Yeah, I like the Tortoise HE tool, which is still, I don't know, it's like a shitty tool from like 99, but it's still better than all the shit like GitHub provides.
Yes,
GitHub
so I can recommend Fork.
Yeah, Fork is good. I like
You can
Fork.
get it fork.dev, and in my experience, it's really by far the best tool for Git, a visual tool for Git you can have, and it's available for both Windows and Mac. Because all the other tools I totally agree with Benjamin.
But it costs like $50 or something to get the professional version.
I don't really understand the licensing model, because you can download it, you can use it, and then sometimes it's asking you to buy a license, but you can still continue.
Please buy it.
So, well, of course, if you use it in a corporate environment, you better should buy a license. But I think if you use private, it's like a WinRAR, which is just occasionally asking you for money, but it's okay if you don't buy.
Yeah.
So you become a hero if you do purchase a license.
Yes.
I mean, even the Git client integrated with Rider, which is kind of okay, but in the end, it still sucks.
But it's a good point. Like half of the time, I'm currently just using the Visual Studio Git integration and just click a button and it works. But when it doesn't work, I have to go out. And
as soon as you have everything which doesn't work out of the box, all the tools are useless, except Fork, which has a nice UI and actually shows you what the problem is instead of some crappy log in your terminal.
Yeah, the Visual Studio 2022, by the way, has a cool feature where you can just click on a GitHub link, open it Visual Studio, and then in Visual Studio you can customize. Do you open just the whole folder? Then you have like a folder view, or just find the first solution it will find automatically and open that one. And that works pretty good. Like you basically just surf around on GitHub, check something out, click on it, then Visual Studio opens, he downloads in the background the Git stuff, and then immediately opens the solution and opens everything. And it's much quicker than before when you have to like, I have to clone it and find the stupid folder, open it, and then click here, click there, do that. And now it's just double click, done. And it just does everything for you, including downloading all the NuGet packages, compiling, and all this cool stuff.
I think now we, like some time ago, we also wanted to start another topic. So I think we are kind of circling back to that about how do we get kickstarted? How do we learn .NET? So what would be, I actually try to remember what was my learning source was actually Benjamin. So I had a mentor. I learned most of .NET stuff. And later on, then a lot of articles, blog posts, videos on YouTube later on, streams now. So this is basically my sources. I'm visiting a lot of meetups since that's the. I'm not sure if I should say that, but everything which has bad sides may also have positive sides. That's for me the good part of the pandemic. There's now a lot of meetups going online. There's a lot of content, a lot of .NET content.
It's easier. You just sit at home and just click a button. You're part of the meetup. Yeah.
Like that's awesome and learning a lot. So how was your getting started with .NET, and how would you learn? How do you currently learn new stuff?
Henrik.
Yes, so like for Stefan, Benjamin kickstarted my career basically and showed me all the best practice you should follow. But going on from there, I mostly I'm subscribed to a lot of blogs, which changed over the time because some of them died, some new popped up.
Too.
Yes, your died too. And since a few years, I think a lot is also going on. For example, on YouTube, like what is his name? One this guy I already forgot, which you also showcased in your last streaming event, Stefan, where you were unsubscribed. This Russian guy or
no, not Nick Jobs.
Yes,
exactly. He's good. He's good.
He's really
very
good.
active the last year.
Yes, but there are some other guys. So
like
basically
500
YouTube at blogs.
Subscribers to like, I don't know, 50,000 now or something.
Yeah, that's basically what I learned. And I'm especially when I'm searching for a specific topic on Stack Overflow, and then I just briefly look on the right side of the related questions. I like to click them and then get lost for the next 90 minutes reading some random questions with random answers. But
oh no,
actually I learned a lot by doing this. It's like the Wikipedia effect.
Yeah, the rabbit hole. Like click here, click here, click here. I want to learn this.
Sometimes it stays on topic, but sometimes it goes completely off topic, and there's something we do something about astrophysics or so.
But at least you're learning something. It's not like TikTok when you get stupider on every click.
At least I learned something.
Yeah, so for me, my main issue was whenever I did anything, there was like either no internet around in the 80s, so you had to learn everything from the book that came with the computer, or just try it out yourself. Like basically you were a hacker completely.
Where this times where you had to order the Microsoft library from Microsoft, and you got the CD.
I got the CD, the MSDN CD, and then in there was like everything. There was like a poster you could print out, but they didn't have a printer. And then there was like a lot of like documentation, like I think it was just HTML, and basically tons of stuff to read, like millions of like lines of text. And it was very useful. Basically, it was your internet back then. So very good.
The only source you had.
But basically, when I started Arena was in .NET, I couldn't ask anyone because no one in the world was doing what I was doing. So I had to figure it out myself. So obviously, it's much easier nowadays where you can just follow someone that did the steps for you. But I always see, like, we have, for example, one developer that does our game project. And a year ago, he didn't program, and now he's a programmer. He can do C#, he knows Unity, he knows all the stuff, but he basically only knows the stuff he touched. Like, he has no clue about anything underlying how it works. Like, he never wrote an engine. Like, he has no clue on all the internal stuff. So whenever he gets stuck, he really gets stuck. Like, it's really, it's much harder for him to get unstuck, I would say, than for someone that has, like, more experience and written an engine before and stuff like that. Yeah, and then I liked lots of blogs. This is a really good point from Hendrik. Like in 2004, the whole blog stuff started. I did my blog and I was reading every day at least like 20 blogs. And I learned a lot from that. Like all the cool people, basically, all the Microsoft people wrote it. And there was lots of like mono development going on. It was very, very interesting all the time. But most of them died like over the years. And sometimes I read it, like the .NET blog is pretty good. Can recommend. They always have like someone writing on some new topic. Then Uncle Bob has a good blog, but rarely he writes. And then lots of books. Like I usually read like, I hear one book at least per month with Audible. And then I read like sometimes like 2-3 books per month. And that helps a lot to stay up to date and learn about interesting topics, like not even coding stuff, but since we're doing lots of machine learning, AI, I want to be very up to date on what the current people are talking about in like any kind of related topic. So I think the best podcast you can hear about this is Lex Fridman. who has like a YouTube channel. It's super successful, like 1 million subscriber, I think he have already. And he even has Elon Musk on. Like he's crazy famous. He just gets the richest person on the planet and just interviews them about AI. And he's also doing AI, and he's also a programmer. And he always wanted to do a startup very similar to ours, to have like robots being clever. But I think he is so successful with his podcast. He only does his podcast now. And every week he has like 2 or 3 podcasts. He's very good. So that's, I think everyone learns from everyone else around you, and you get better the more good stuff you have, the more good input you have.
Yes, that's true.
I guess recently I now also learn a lot from reading through code from GitHub, from some awesome
reading code,
if it's good code.
The awesome libraries that I use day to day. I couldn't live without. Perhaps
you checked it out in detail.
What's going on there?
But it takes a lot of time, I guess, to read it and understand it.
It does, yeah, but the payoff is huge.
Mm-hmm. So I remember back in the 80s, I basically went to the library and physically got like a magazine, and in the magazine, because it was like kind of expensive, like $10, and I just like got the old magazine that was in the library, and in the magazine there was like source code, like written with either assembly or like basic, and you just written down like 3 or 4 pages of text and then pressed enter and then hope you didn't mistype anything. And then you had some program that did something like some cool puzzle or game. Usually it was some kind of game or like some fun thing, but you always made some mistakes somewhere. So either the app didn't start, or it did start, but then it didn't produce what you wanted. And then you had to go through every single letter and check where you did the mistake. But that helped a lot to like understand it, because in the beginning you just had no idea. You just type something to the screen and then, hey, something happens. I like it. And then it takes a lot of time to get from this step. So that's basically what I'm saying. Like the developers nowadays just type some stuff and it works and they're happy. And they know how to do it, how to copy paste from Stack Overflow and paste it in their code, and it kind of works. But when it's not working, then they're completely stuck, because they didn't take the time like you did to check actually what's happening, understand like the whole mechanics. And then at some point you have to do it. Like it will not always work out of the box all the time, because the problems get complicated and you have to understand what you're doing. And so I'm pretty good at that. So for me, it's never a problem, but I see this a lot in my developers. The less experience they have, the worse this problem is of understanding what to do in case of trouble.
Mm-hmm. Nice.
Especially like we are now close to the release of the game, and now all these big problems pop up. Because early, like you do, oh, let's do this, let's do that. It looks cool. And then in the end, now we put it all together and it just explodes. And fuck, what did we do? Not good.
Well, I now remember when I started, and also when I hit the problem, then it was like, oh, what I'm doing here.
Yeah, it makes you humble, which is good.
Well, I had the right people in my life, which always gave me a little push and helped me out.
And do you mentoring other people now? Are you like the leader now in some area as well?
I am trying to get there on a more of a low keys thing. So
because Edwin said like he's also like sometimes project manager and has to manage like other
not project manager, but technical lead, yes.
Like technical lead, something like that. And then you kind of like take your wisdom and just by like ordering to do them some stuff, you give it to them as well.
If they are willing to listen, yes.
If they're listening, yeah. If they're following your advice, obviously. It's always better to be a boss, because if someone is not following my advice, I can just hit them or fire them.
Yes, I cannot fire them.
Yeah, that's not good. if they know that, they should not know that.
My dad always says life is about taking, but also giving. So
giving is very important.
So I'm publishing projects on GitHub.
Yes,
going to meetups and sharing experiences that I had, and also
you were even on the NDC conference this year.
I was, yes.
Very good.
This was an amazing experience. I hope there will be more. Fingers crossed.
Yeah, cool. Good luck.
Thank you.
If I had more time, I probably would be more involved as well. So I think 10 years ago, I was going to all kinds of meetups as well, like including Xbox meetups and XNA and .NET, and it was interesting in everything. But yeah, it took a lot of time. And then like I saw like these people going this way and these people going this way. And then I focused on the game development meetup we have here in Hanover. And I was even hosting it like for like 3-4 years when the main guy left. And it was like merged shortly before Corona, I think 2019, with the Unity meetup, which had like way more users. We only had like 2-3 people coming, and they had like 50 people registered. And then we just merged them both, and now it's like it's running on itself. So I'm not really involved much anymore. But my main issue is like with that meetup, it's all students. Like it's people that just like learned programming like yesterday, and now they're showing off the day they did today, the game they did, and they're talking about tech, which is like very like I'm just learned it. Like it's very interesting, and they're all excited and it's cool. But for me, it's like very boring. Like I know this kind of shit already. So it's like if someone like would tell a doctor like, oh, I learned something about how the human body works, and the doctor's like, yeah, I know, I learned this for 10 years. You don't have to tell me. And so that's basically why I still like it. And sometimes I go there and we have like they have game jams usually twice a year, like in the beginning, the global game jam, always in January. And then summertime they usually have one with like nice atmosphere. And like with Corona it's not possible, but maybe this year it's possible again. And then you can meet many people, and it's even cool, old people and young people, and they're all doing game jam and some game. It's really cool. I like that. Yeah, it's cool to have meetups.
I think I now have the same feeling that you mentioned, I guess, in the beginning, that .NET is so big. It seems that every day, although I learn something new, overall I seem to learn less about .NET. It's going
there's
fast.
more coming than you can learn. Yeah, exactly. But it's the same for every big technology. Like the Amazon guy cannot know what Amazon is doing anymore. It's just too big. And every day it's getting bigger. They're hiring more people and he's more out of clue. But it's a good thing. Like, why should one human have everything? Like, you need many people.
So perhaps this now goes into a bit of a closing question. Will I still be doing .NET in 20 years? Well, currently
Me not.
I would be naive and say yes, of course. But how do you feel?
It's a no for me.
Because you want to move to different tech?
Yes, basically I'm developing my language as to replace .NET. So that's the whole point.
That's a bold goal, yes.
Yeah, it's not replace it for everyone. It's just for my specific goal. I still want to use .NET. It will be very important the next years, especially with all the cool stuff that's coming. But I still think long term it's lacking something. And I don't know in which way it will evolve to. But for example, Java, like I would not like to use for the next 20 years. It's not fun. And yeah, something like Python is cool, but it's not really getting better over the years. So there's lots of like cool new languages that gets lots of hype, like Rust and Go, that is for specific communities really cool for doing some stuff. But I don't think in 20 years we will have exactly the same languages as today. Like there will be new stuff being invented. And it depends on the use case. Like if you're doing games, like some game engine thingy that does 90% of the work is probably the thing that will still exist. But yeah, other technology needs other stuff. But I think Microsoft is in a good way for world domination. Like they still have the best stuff. Yeah, it's crazy. Like they're just buying all the game development studios. So Blizzard is now Microsoft. What the fuck? So all cool. Strategy games, Age of Empires, StarCraft, Warcraft, they all belong to Microsoft now. It's very strange.
Yeah,
maybe
so
their bias next.
Quite confident that I will still use. Well, first of all, I'm sure the .NET ecosystem will still exist in 20 years, and also quite confident that I will still using C#. But maybe I'm also using something else, but that's something I clearly cannot see. Like Benjamin said, for example, I really like Rust, both as a concept and what you can do with it, because Rust is one of these few languages which does truly new things compared to other languages which just, oh, you don't need braces anymore. Oh, it's so innovative, great new feature. And Rust is doing really new things. So maybe I will get into more of it. especially useful for if you do like low-level programming. So in the past, you had to use C or some crap, and now you have Rust, which is like a type-safe memory or mostly memory-safe language, and it's way cooler to do it. But you can still like code for your microcontroller from Alibaba for like $1. So it's really cool. Yeah, we will see. I don't know. I mean, you can combine these languages. It's no problem. You use Rust for your embedded stuff, and you write your backend in .NET. So it's not an exclusive decision, I would say.
Someone just wrote me the sound level is a bit low for the stream. Strange. It's a bit late to say that. Stream is over.
I put it on my list and review.
But I'm really curious how C# as a language will evolve over the next
will there be
years.
C# 14
because it's already so feature packed. Like if they continue on this current rate to add features, it will be so complex that basically no one can learn it anymore.
Yeah, it's like C++. Like you just add more stuff. And since of the backward compatibility, like even the C, you cannot break anything. So you just make more stuff. And if the programmer does it correctly, you have nice code, but he can also do it incorrectly. And obviously all the code bases in the world will be a mix of everything. And I don't think that can be the future. Like, I don't think in 100 years, anyone will still look at this and say like, oh yeah, that's the right way to do it. There will be some different way we come up with.
I mean, I just quickly looked it up. C# already has, just let me calculate, 72 keywords, which is insane. Like, what the fuck?
My language has like 8 or something.
Really and most of them you never use. Like,
no.
When is the last time you have used like a label, like a go-to statement?
Like the assembly stuff. Yeah, good point. Like C# still has complete compatibility with the assembly. So you can write at any point some assembly code, which is retarded because the assembly code won't work on all platforms. So now you have to write assembly code for each platform. And it's like, there's not even code to manage that. You can just say, here's assembly, and I'm assuming you're on the right platform. Now execute this. And so you have to do all your own stuff to figure out.
When was the last time you explicitly declared an event using the event keyword?
Yeah, event is pretty
I cannot remember.
I think in UI in like WPF, it would still be used, but like in my own code, I would not use it.
This was also mentioned in the chat previously. That since with a func, action, and predicate, most use cases are covered. Rarely the definition of a custom event is necessary.
It's also so ugly to use. Like it might be useful if you exactly have the use case, but in all other cases, like that.
Yeah. So my guess is that maybe like within the next few years or like 10 years, they will create a new language which will be inspired by C#, but will be like
on the .NET, but it's better, yeah.
Like a C# 2.0. In fact, there was also a research project from Microsoft called C Omega, which was basically a research project to advance C#. And actually, it's the origin for Link, for example.
Yeah. So the Link stuff came there.
Really interesting. And I think in the long term, this will happen with C#. There will be some iteration with a new name, which will be like, take the best part, but throw away all the shits. And then you have like only 12 keywords or so. But
I think originally they wanted to name like all the languages C in the beginning. I think they want to name it cool. Yes. And the problem is like you cannot name something cool. So some like committee like at Microsoft said like no, and they searched for a new name, and they came up with C#, like the most horrible name for any search engine. You can never find anything.
It's because it had C. Was it inspired by C++?
Yeah. And then C++ memes and all this kind of stuff. But many languages have this problem. If you type in Java, like you find everything out about coffee. And in the beginning, it was very hard to do any like proper search because you just type the keyword of the language and then something else. But these two words together for search engine is he's interested in coffee and he wants to know where to find coffee. So let's show him that. Like, no, I want to find out something about some keyword. Rust, I think you find the game instead of the programming language because the game is much more popular, I guess. And Go is a horrible name. I never find anything with Go. It's impossible. Like, how do you write Go in the browser? Like, what the fuck? Like Go and then if, like what? Go if? The browser's confused. It's not
naming
good.
is hard, isn't it?
Yeah, but C++, you type in C++, you find exactly C++ because no product in the world is named C++. So it's very clear what you mean.
Mhm.
So it's just C# is like a bad thingy for the, and I think sharp was like a special letter. So it only passed C and then ignored the rest. And yeah, but I think now it's better. Like now you find stuff like Stack Overflow, obviously, very big.
And the abundance of Microsoft documentation.
Yeah. And I think most people don't actually search so much. So I search a lot every day, but I saw like, especially for my employees and also what I see what younger developers doing, they basically just watch some like stream, like on Twitch or like mostly on YouTube, what someone else is doing, just repeating the steps. And that's the way they learn it, basically. They don't like ask the question, they just follow someone along like a lecturer, like a teacher. And then in the end, they're just fiddling around and changing some values and learning that way. Okay. So instead of like reading documentation and doing all the stuff that like you should do properly, they just watch someone else do it.
Mm-hmm.
So
it's great if the instructor is
there's some good ones.
Has a good quality, but it's not then that's also my problem with like GitHub Copilot was just garbage, because most of the code on GitHub is garbage.
Exactly. So. And they did a new thing with the Copilot that was solving like programming problems like months ago. And like 50% of the problems you could solve. But actually, if you want to look, you can check out the source code there, like on OpenAI. You just have a thing you can click on and see what the bot does. And basically, it produces the most horrible spaghetti code you have ever seen. Like everything is like A, B, A, J, 1, 2, 3. And you cannot understand anything. It's like a black box, but somehow it solves like in a complicated way the question like, please add 2 numbers. And then it does like 50 lines of horrible code. And somewhere there's a plus inside and it generates that randomly. And it's doing that based on what it saw on other people repositories on GitHub. Like basically it takes the words of the question and then somehow merges it into a solution. And people think this is like amazing. And
but isn't this like a general AI problem that there for you is no way to know how the system came to a solution? It's just present you a solution. Yeah. And if it does not work, you have basically no idea why it's not working. And so you have to change your training data to get another output.
Yeah. So for us, we currently
so you cannot debug it like in a classical sense.
It's even worse because every time you change anything, like any parameter, you have to delete everything and start over. Because if you just take the existing data, it's like it's tainted by the problem that you had previously. And if you just add some new stuff, like let's say we want to figure out in the new light condition, like it's like a different light now, then all the old data that was training the network made the network work in a way that is not longer working. So basically you have to kill it completely, shoot it in the head, and then start over. And you have to do this like many, many times, like millions of times. Like it's usually automated, but it's really stupid. Like it's not like you wouldn't shoot like a human just to teach him something else and make a new human and teach the new human how to do it. You would change the existing human. And I think that's the main problem with AI. You cannot really, there's like this transfer learning, but it doesn't work. It's like the most horrible, shitty thing ever. And the main problem is you don't know how it works. It's just too complex and it's too many neurons. And yeah, it's a big problem. But we're trying to working on it.
So that means I will still have a job in writing code in the next couple
of years. The think Copilot, like everyone thought last year, everyone will use Copilot. When it's finally out of the beta, we can all use it. And I like the IntelliJ suggestions, like the autocomplete, which is like 50% of the time is saying something useful and 50% is completely useless. But it's kind of cool to have like, if you just wrote 3 times a function and every time you had a return and you just type R and it autocompletes the return and suggests like, oh, in this case, you probably want to return the thing you just created, and then it just pastes it there. That's kind of cool. Like it works and it's nice for that, but that's not intelligence. That's like a nice editor feature. Like my Notepad can do that already, like 20 years ago. Notepad++ has this feature. So it's a bit better now, but it's not intelligence at all. It's a nice feature.
Yeah, and especially most of the time, this automated systems only work well if you give them a very strict formal definition of a problem, which in real world will never happen. It's just some random customer yelling at you
And
do
you have to
this.
first understand it, what he wants. Yeah.
Yeah.
And he doesn't even know what he wants himself.
And I will, at least at this point in time, not even be close to solve this. Like,
No, exactly.
Makes no sense.
Yeah, good point. But it's still cool what they're doing. Like OpenAI has really cool stuff. Like the games they're solved, and now the Copilot stuff with GitHub, like searching all of GitHub and reading it and using it as an input to train an AI. It's a cool idea. It's just not that easy. That the problem is the journalist. I think the journalist always says like, "Oh, look at this, amazing! It will change the world," and completely clickbait stuff. And then the funny thing is, a week later, everyone forgets. Like, what was this? Like, just bullshit for 1 week. So strange. Cool. I think we talked about everything. Like,
I'm having right now a look at our cheat sheet. Are there some some thoughts that would be perfect for closing?
I would say if anyone wants to learn .NET and is not that comfortable yet, first of all, go to the .NET website. So that's .NET.org, and everything is there and free. And then if you want to be more advanced, there's lots of YouTube channels. I think on Twitch, there's not much, so don't look on Twitch. But on YouTube, you can find tons of like tutorials, depending on what you want to do, like game development. There's a huge amount of stuff with Unity. And if you want to do proper programming, read the Uncle Bob books, Clean Code, the Clean Coder. There's actually 8 books, I think now. Clean Craftsmanship, Clean Agile, Clean Architecture, Code That Fits in Your Head is the newest one. I hope I get it tomorrow.
Yes.
Yeah, it's cool.
Do test-driven development.
And then
very important.
I noticed like for very new people that didn't program before, to teach them test-driven development is kind of easy. You can force them to do it. And like when I was teaching in school, I could also teach the people, they had no programming experience ever. And after like 4 hours, they all were doing test-driven development, because that's the way I taught them. This is how you solve your problem. You want to do like a calculator, add 2 numbers, and we first write this test. And they didn't even know there was another way. They just did it. And then if you have like experienced programmers, like with 2 years, 3 years, it's almost impossible to teach them anything, because they know how to do it and they want to follow the hacky way. And then you have a super experienced one, 10 years, and then he either like did already test-driven development, or he understands the issue and can just adapt to it. But the in-between guys are really difficult. Like anything between like 2 and 5 years to convince them to do it properly, it's hard. It's not so much fun to teach those guys.
This resonates, which was written in the chat. So it depends. It seems to depend a lot on the first, well, especially on the first hands-on experience in the first peers.
But
you
also on the mindset.
Yeah,
because I think like programming area, there are a lot of special people anyway. Like you wouldn't find like in this concentration in other industries, which are very well, how to say it, like they have strong opinions, and if you tell them that maybe it's not the best idea
kind of person,
how to solve a problem, they take this personal very quickly and start like feeling offended and trying to defend themselves, even if there's absolutely no reason for it. But I encountered this a lot of times, and I think like in the software engineering is especially bad there.
Yeah. And if you're coming from a more hacky environment, let's say you come from Linux doing command line stuff in HackerOn, really good at that, it's much harder for you to like go in like a proper job where you just have to do 9 to 5, like you open this database, get this data, do it like this way. It's not the way you like to do it. So you like the hacky way more. And lots of people from university just learn like in Python, you do this, do that. And like they never were taught like the proper way to program. Like they don't even know how to make a program that you can just click on and run. They only know how to write some script. And they have no clue about how is the script ever executed, because they never had that problem in their life. Like the professor just taught them, like, solve this, do the script, give me the script, and I look at it and say it's okay. But then later in life, you have the problem, like, please, like, make a complete product, like build a website, build an app or whatever, and they don't even know what to do. Like they're completely confused. Like, what? I have only this, and then I type in Google how to make my script like into an executable and use some horrible hacky way. And I think that's the thing. Like the schools should get better, and like there should be projects. Like let's students, or I think in school you should learn it. Just make a project. I think Elon Musk has like made a school at Tesla for the employees and for his own child. And basically, I think he said like in grade 4, to just learn how to make a motor. So to just put in a room, here's your stuff to build a motor, now learn it. Now let's go ahead. And they actually they have to build a motor, and they have to learn all the steps and understand how to do it. Or like in our case, it would be like, let's make some console program, like make a text adventure. It's not that difficult. You can do it in
understand
1
how
hour.
stuff actually work instead of it's
Exactly.
just magic.
And you have to do all the steps. Like you cannot just say, I make my text adventure and I forget about the input. Like it doesn't work. You have to ask the user the input. You have to give the program to someone else. So you have to figure out how the fuck do I give it to him? Like, do I make like, give it to a bird and it flies over, or do a zip file and put it on a USB stick? Do I send it by email? Do I use GitHub? And obviously this might take some time. Like this may take like a few more days to understand it all. But then you have like the basic concept of what you need for cooperation and interaction with other people. But you have to do it. And I see most people didn't do that. Like that's my main issue. Like I'm looking at someone, asking him, what did you do? Do you have anything to show? And it's all research stuff, or it's completely under NDA and they cannot even show it to me. And then I don't even know what they can do. It's very difficult. But I guess that's more a hiring problem for me.
I see.
So I guess you guys are lucky you have already people that know what they're doing. So some of them.
So equality in the chat wrote that it seems to be easier to teach somebody when they are earlier in their career. So to understand correctly, so there is actually 2 components. So there needs to be the right mentors and teachers early on, but then as an individual, keep an open mindset to still be learning all the time.
But I think you don't have to have a good teacher. Like if every school would just teach like Uncle Bob, like how do you program, just do like the lessons, just copy paste, don't even be good, it would be way better than it's now. So it doesn't have to be perfect. Just the problem is not taught at all. Like no one knows any of this stuff. And you just figure out much later in life, like, oh, fuck, I have to do, this is the way I write a program, or this is how I deliver it to the customer. Like, let's say I'm making a game and I have players, and the players later will be mad if there's like some bug in the game. And this whole process of doing this is like super useful to do. And why not learn it like early on? Like no one does this at university. Even if there's some project, they have like some cool, let's do all a Unity game. And at the end you get rated by it. And like whoever does like a cool puzzles thing, none of these games are any useful because all of them crash immediately. They're the most horrible user experience ever because they never have done that. They have no idea how to give it to like an end user and then listen to the end user and fix the issue and go through some iterations and fix some bugs and stuff like that, which is what most of the time developers do. Like we're not like inventing new shit every day. We're just handling problems we had yesterday and trying to make them better. Yes. Good. Should we do it another time, like at 30? or earlier?
Perhaps sooner. Yeah. I had a blast, and it was for me personally a great opportunity to connect with you again. Have a lot of nostalgia, and would be sweet to perhaps repeat this one day. Cool. So thank you two very much for joining in. Some closing thoughts, some project you're currently working on that you would like to showcase, other than things we have seen already.
Yeah, so my main thing is currently the strict thing I do, like the stuff we do at the company. It's like machine learning, trying to make robot arms smart. We're also doing like a game. So towersgame.net is the website, and hope to release it end of the month. So lots of projects going on, and maybe next time we talk a bit more when it's actually released. And we are actually hosting it on the Towers channel right now. So maybe some random people. And I think you also wanted to put this on YouTube, like after.
Yes, I will have a look at it. It seems that I definitely had some issues with I'm using Twitch Studio and Zoom, and it seems that the audio quality isn't all too good. I will review it, and if nothing else, I will learn from my mistake and then make it better next time.
Nice. At
That's
least you
good.
learned something.
So this is my third stream actually. Yeah, there's still a lot for me to learn.
Next time with green screens and other stuff.
A lot of stuff to do. Cool. Then I want to thank you very, very much.
Yes.
And yeah, so here it is for 20 more years of .NET.
20 more years of .NET. Oh yeah.
Okay, hopefully we meet again.
Yes.
Bye-bye.
Goodbye. Stay in the chat.
Sure.
Let's do a closing session afterwards. But now I'm closing the stream if I find the correct. Yes. Yeah, I have I need some hacky thing here going on.
Did you see how many people were watching? In the end, I saw like 10. Like, was it more in the middle? Now it's 11.
So I will follow up afterwards.